Before we talk about inverse functions, let's talk about functions. So I'm going to use sets to start. So if you think about what a function is, from the domain or the input, we're going to follow some rule and it's going to go to the output. So you think of something from the domain, mapping it over, following some rule. So f will be our rule that we follow, and we'll get f of x if x is our input. So for example, if we had f of x equals 3 times 2 to the x. Alright. And if I was to create a table for this, for 0, 1, 2, 3. So my output, so I can pick any input I want for this function. This is a function because as you pick your input, if I go 3 times 2 raised to the 0, we're going to get 3 times 1, anything to the 0 exponent's 1, and we get 3. 3 times 2 to the first, 6. 3 times 2 squared, well, 2 squared is 4 times 3 is 12, and 3 times 2 cubed, 2 cubed 8 times 3 is 24. And just like our exponential functions, you can see that it's doubling each time. Okay. Now this is a function because no matter what you put in for x, 2 raised to that, it's only going to be one answer. We're only going to get one answer. 2 to the 0 is 1. There's nothing else. So 1 times 3 is going to be 3. So this is a function because for every input there is exactly one output. Okay. So again, if I go back to my sets, so if I just have some point going to some other, another point going to another point going over to that same point. So if I label these, let's say 1 goes to 2, 3 goes to 4, and 5 goes to 4. So again, 1 goes to 2, 3 goes to 4, and 5 goes to 4. Yeah, if you want to look at it as points 1, 2, 3, 4, and 5, 4. Now, this is a function. Because if you look here, every input has exactly one output. So if I was to say 1, if I say the input 1, the output's 2. 1 only goes to 2. If I say the input 3, 3 goes to 4. 3 only goes to 4. If I say the input 5, 5 goes to 4. 5 only goes to 4. That is a function. Versus if I look at this relation, so we'll say reverse the order. So if we say 2 goes to 1, 4 goes to 3, 5, so 2 goes to 1, 4 goes to 3, but 4 also goes to 5. So, which is it? If you have one input going to 2 different outputs, this is not a function. There can't be any choices. So when you have an input, it can only go to one output. It can't be split and go one direction or another direction. This would not be a function. Okay. So if we think, now let me do it again. Here's a set. Think of this set being not numbers, but students. So here's a student, and here are classes. We'll say a class at 10 o'clock. Okay. So a student goes to some class at 10 o'clock. Another student goes to a different class at 10 o'clock. Another student goes to the same class. So you have 3 different students, but 2 students are going to the same class. That's not a problem. That's a function. When would it be a problem? Is if you had, so here's a student going to some class. Here's a student trying to go to 2 different classes. So again, student, classes, class at 10 o'clock. This could be in English, math, history. So here's one student trying to go to 2 different classes at the same time. So this is not a function. So for every input, there has to be exactly one output. All right. So in order for a function now to have an inverse function, what has to be true is, if you think about it, we have to be able to go in both directions. So from here and back, here and back. The inverse is going in that other direction. So in order for a function to have an inverse function, it said we have to it has to be 1 to 1. For every input, there's exactly one output, and for every output, there's exactly one input. So a function is going to go this direction. You know, here's our input, here's our output. The inverse is going to go back to where we started. It's going to reverse that direction. So if we start, so here's my x following my rule f, and I'm going to have my f of x. But something else I want to notice is that this is the domain, this is my starting domain of f. And this would be my range of f. But for my inverse, I'm going to start here and I'm going to go back the other direction. So this would be my f inverse. This is a symbol for inverse. That -1, f to -1, that's our symbol for inverse. But if we look, notice here's where I'm starting as I come. So this is the domain of f inverse, and this is the range of f inverse. So if we notice, the range of f is the same as the domain of f inverse, and the domain of f is the same as the range of f inverse. So what essentially they're doing is they're reversing the roles here. All right. So as we look now, let me get, so as we look at our function, what this is really saying now is f of a equals b, then f inverse of b has to equal a because it's going that other direction. So if I have a table here, x, f of x, and we'll say -3, -2, -1, 0, 1, 2, 3. The 1/8, 1/4, 1/2, 1, 2, 4, 8, And if you're wondering what this function is, this is 2 to the x. Now for x, f inverse of x, so this is my domain of f, this is my range of f. So what's going to happen is they're going to switch roles. This range of f is going to be my domain now. If I start with 1/8, 1/4, 1/2, 1, 2, 4, 8. And what happens is, if -3 goes to 1/8, then 1/8 is going to go back to -3. They're reversing the roles. -2 goes to 1/4, then for the inverse, 1/4 is going to go to -2. Half, -1, 0, 1, 2, 3. So again, notice the domain of f is the range of f inverse, and the range of f is the domain of f inverse. So it's important to understand that they are reversing the roles. Now, this here, we will get to it soon, but I'm going to put it down here anyways. What would the inverse function here is going to be log base 2 of x. So we will start getting into logarithms in chapter 2. You do not need to know that right now, but just know that they are switching roles when we talk about the inverses. They switch roles. Okay. So now if we were to look at those graphically, so here's our exponential. So this one right here is going to be that y equals 2 to the x. That was our first table we had. And if we plot the points in the reverse, as we switch them, so this is 1/8, -3, 1/2, or as we go through, 1/4, -2, 1/2, -1, so on and so forth. In that table, we're going to have that curve. This was that, what I referred to as log base 2 of x, something we're going to get into. Okay. But for an invertible function, f and the graph of f inverse is the reflection of the graph of f across the line y equals x. So this is always going to be true. If two functions are inverses of one another, then they're going to be symmetrical to this line y equals x. Now, something else that you've had previously is if a graph passes the vertical line test, then it's a function. Well, now if a graph passes the horizontal line test, what's that saying is the inverse is a function. So if you can imagine a horizontal line, but when we switch roles, that horizontal line of x equals 2 is going to, or y equals 2 in this case, horizontal, would become x equals 2. So the horizontal line on the function is going to be referring to the vertical line on the inverse. And you can see how it passes the vertical line test. So you have a vertical line test, tells you if it's a function, and a horizontal line test will tell you if the inverse is a function. So now if we look at an example, if we say, or better yet, let me show you. So on your calculator, I got to turn my plot on. So if you're just graphing, make sure your plot's off. If you're modeling or something, list 1, list 2, then your plot has to be on. But if your plot's on and you're trying to graph something, it could cause a problem. So we're just going to have some easy functions. We're going to say x plus 2. Okay. And we'll go zoom 6 for a standard window. Now the nice thing about your calculator is if you can see it, now we could actually in this draw menu here, so second program, you can see we can actually draw different things in here. And look at number 8 as draw inverse. So I'm going to draw inverse of what I put in. So vars, y vars function y1. So I'm going to draw the inverse of y1. I haven't found it yet, but I could just draw the curve. So when I hit enter, let's see here. Did I draw the inverse? So as we look at that now, they're going to be symmetrical to that line. Now I'm going to put it in y 3, y equals x. Okay, and I'm going to bold it a little bit. All right. So if I graph now, notice how that's split. Now what this really means is if we fold this on that line y equals x, we should get this other graph. Now this isn't a very good one to see it. If I go y equals, let me go ahead and change. If we go y equals, let's try x cubed. And if I graph that now, so here's my x cubed, here's my line y equals x, so now my inverse to that is going to be symmetrical. And if you think about how do you undo a cube, it is going to be the cube root. So if I go math, I'm going to do the cube root of x, or you could do it to the 1/3 x to the 1/3 power. But I want you to see this a little better. So I'm going to go window, instead of negative 10 to 10, I'm going to say let's go negative 5 to 5 and negative 5 to 5. We're just going to zoom in a little bit. So you can see there's that first one, and as I come up, here comes the other one. And I hit enter, so it's paused now, so you can see how that's still moving because I hit enter to pause it. But I want you to see how that line y equals x is going to go right through the center of both those. And here's that line y equals x. Now if it looks like it's skewed just a little bit and it's not perfect, well that's because your window is stretched in one direction versus the other. Even though in the window it goes negative 5 to 5, the pixels are really in a 3 to 2 ratio. So if you want to see a square window, you have to go zoom and then go down to 5 for that square window. And then it'll square it up and it'll look more symmetrical to that line y equals x. But that's really what this one's saying. So from a graph, and if you think about it, if we go x f of x, and I'm going to do where f of x equals 4x minus 5. So if I say negative 1, negative 4 minus 5, negative 9, 0, 4 times 0 is 0, minus 5, 1, 4 minus 5, negative 1, 2, 4 times 2, 8 minus 5, 3, and 3, we get 7. So now x f of inverse of x, so this is negative 9, negative 5, negative 1, 3, 7. So if I was to plot these points, negative 1 goes to 9, but on the other function, negative 9 goes to negative 1. 0, 1, 2, 3. So we're reversing those roles as we go back and forth. So if I come back to here, and let's go, I'm going to clear this out, and I go 4x minus 5. And I'm going to graph. So here's my 4x minus 5, and if you want, in y3 I'm going to the x again. And if I graph now, so I'm looking for that line that's symmetrical to this line. So it looks like it's going to be something like here. if I draw my calculator. Okay, because if we fold it on this line y equals x, it has to, this bottom half has to match up. This one would have to match up with that. So now, how do we find it? Well, we're going to do it more mathematically shortly, but I just want to kind of follow through what those steps would be. If I tell you what x is, if I said x was -1, what did we do? We times it. So we're going to have some input, and then when you plug it in, you're going to go 4 times that input. Then you're going to take that result and subtract 5. Okay. Well, if we want to get the inverse of this function, then we're going to have to do starting down and work our way backwards. We have to undo everything we did. So we're going to have our input over here. And what are we going to do? Well, remember we're working backwards. So instead of subtracting 5, we're going to have to go our input plus 5. Instead of 4 times, we're going to have to take that result. And instead of 4 times, we have to take that result and divide by 4. And that would get us back to our beginning. So now what would that look like? So f inverse of x, again this is my symbol for the inverse, equals, my input is x, I'm going to add 5, and I'm going to take that result and I'm going to have to divide by 4. So it's everything divide by 4. And this is my inverse. Now how can we check it? We can check it graphically by, let's go ahead and put this in. So now it's everything, so I need parentheses there. And what was it again? X plus 5 divided by 4. So x plus 5, close my parenthesis, divided by 4. And now when we graph, we should have pretty close to that line. So that when you folded it, you would get those pieces. So we can check graphically. It has to be symmetrical to that line y equals x. We could graph the inverse. If you know 1, the inverse, you're just going to switch roles. So if this is 0, 1, its counterpart is going to be 1, 0. If this is 1, 2, its counterpart is going to be 2, 1. They're going to switch roles. And again, that's what this is doing. Because as we go from our function, our inverse is working backwards. So now, how do we find the inverse? Mathematically. Now, I will say I do not like how your book has this worded. So the first one, so if we start out, if f of x equals, we're going to do it again, 4x minus 5 with the one we just found. So my first step, that one's okay. Replace f of x with y. So y equals 4x minus 5. Now I don't like step number 2. So we're going to get rid of that one. And this time we're going to switch x with y and y with x. Now remember how we were talking about how they switch roles. So it's going to be x equals 4y minus 5. Now, why do we do that? Why do I have you do that? Is because now our next step is we're going to solve for y. In most of your math career, you've been solving for y in terms of x. So I really don't want this to be anything different than what you're used to. So how do we solve this for y? The first part is, so we're going to add 5. So we get x plus 5 equals 4y. Now we're going to divide by 4. Divide by 4. So y equals x plus 5 divided by 4. Now our last step back here is we're going to replace y with f inverse of x. So this is f inverse of x, so we're stating that the inverse is x plus 5 divided by 4. And if you look back to what we did before, we came up with the same thing working backwards. Well, with these steps here, we could find it mathematically, and I think that's going to be easier for you than what you have in your book there. So now if we do another example, and this time we'll say f of x equals 2x cubed plus 7. So our first step is replace f of x with y. Now switch your x and y. Interchange them. X equals 2y cubed plus 7. So this is step 1. This is step 2. Now step 3, we're going to solve. Minus 7, minus 7. X minus 7 equals 2y cubed. Divide by 2. So we get x minus 7 over 2 equals y cubed. How do we solve for y? We're going to take the cube root of both sides. So we're left with the cube root of x minus 7 over 2 equals y. And then don't forget that last step, f inverse. So this is our fourth step. F inverse of x equals the cube root of x minus 7 over 2. So there really should be a fifth step here. Your fifth step should be, if you have time, check. So if we go, let me use the other one here. So if we go y equals, clear, I'm going to turn that plot off again. So 2x to the third plus 7. And my inverse is the root. Now instead of doing a cube root, I'm going to do it as an exponent. So we have to put a bunch of parentheses in with this. It's going to be x minus 7. So that's in parentheses. Divided by 2. And all of that was in parentheses because that's under our cube root. Raised in parentheses, we're going to put that 1/3 power in, which is representing that cube root. Now if I go zoom 6, we should see something relatively symmetrical. Again, remember it's skewed a little bit in a 3 to 2, but you can see that line y equals x, and like I said, we could always put it in y3. Just put that x in, and I scroll way over to the left, hit enter once, will make it darker. So now when I graph, it's just going to be a bolder line. And see that that's pretty symmetrical. If we go zoom square, it'll look better for being symmetrical to that line y equals x. And if we look at the window, this is what I meant by that 3 to 2 ratio. But zoom 6 is just kind of stretching your x-axis. But it should look relatively symmetrical. So if you want to do just a couple more examples, so determine the inverse. Y equals 4x plus 3 over 11. Interchange your x and y. X equals 4y plus 3 over 11. Solve for y. Well, this one I'm going to multiply by 11 first to get rid of that fraction. Whatever you do to one side, you have to do the other. So this is 11x equals 4y plus 3 minus 3. 11x minus 3, not like terms. 4y, divide by 4, divide by 4. So we get y equals 11x minus 3 over 4. And don't forget that last step. F inverse of x now is 11x minus 3 divided by 4. So you try this one. F of x equals x to the 5th plus 3. The inverse, well, I guess we'll do it. Y equals 4x to the 5th plus 3. Switch your x and y. X equals 4y to the 5th plus 3. Solve for y. X minus 3 equals 4y to the 5th. Divide by 4. X minus 3 over 4 equals y to the 5th. Y equals the 5th root of all of that. And then F inverse of x equals the 5th root of x minus 3 over 4. Now, another way of checking it is come back up here and pick some value. If x is 1, what's y going to be? So 1 times 4, 1 to the 5th is 1 times over here, we know 1 goes to 7. So if we look at the inverse, what should happen is the reverse. I'm going to start with 7. What's 7 minus 3? 4. 4 divided by 4, 1. The 5th root of 1 is 1. So it should take you back to your beginning. So here's an exponential curve. Now, say you don't have the equation and you still want a graph. So sketch the graph of the inverse. Pick some nice points as you go through. Or first, I'm going to look at the domain. This is going to go in the entire direction. So as I start in here, let me get an orange marker. So if I'm calling this my f of x, then my domain is going to be all real numbers, negative infinity to infinity. It's all real numbers. My range for f is going to be, it's going to get closer and closer and closer to 0, but never getting there, and up. So it's going to be not getting, so it's going to open parenthesis, 0 to infinity. So, and as I look at some of these points, I notice this point right here is 0, 1. So I'm going to reverse that order. Instead of 0, 1, it's going to be 1, 0. So it's, here's my 1, 0. Here's another nice point, which is over 1, 2. So if we have this point, 0, 1, 1, 2. Let's see, this one's nice. 2, 4, 3, 8. So now when I'm plotting my inverse, it's going to be 1, 0, 2, 1, 4, 2, and 8, 3. So there's my 1, 0, 2, 1, 4, 2, and 8, 3. And then as it gets closer, it's going to get closer to my x-axis, my y-axis. So our graph is going to come up and turn. And again, it should look something pretty symmetrical to that y equals x. Now what's the domain of this function going to be? The domain is going to be the range up here. So instead it's going to be not all real numbers, but 0 to infinity, and notice how it gets real close to 0 and above. The range is going to be, since it goes down forever and it really goes up forever, it's going to be negative infinity to infinity, all real numbers, which is what the domain was here. So notice the domain is the range of the inverse, and if this is our f inverse of x, this would be the domain and range of our inverse. And we could do the similar down here. Notice 0, 0, well, that's still going to be there. 1, 1, that's still going to be there. Looking for another nice one. Here's 4, 2, so it's going to be 2, 4. Let's see, is there another right here? 9, 3 is going to be 3, 9. And what you're going to have is half of a quadratic. So I say half because notice we're not going to have the other half of a quadratic because that would fail the horizontal line test, which tells you that the inverse would not be a function. If we had a parabola here, it would fail the vertical line test telling you it's not a function. But this is domain and range on both of these would be greater than or equal to 0. But hopefully that helps you with section 2.1 inverse functions, and hopefully you have a better understanding of functions and inverse functions.